So this is demo video for Lab6. I'm Luis Medina and my partner is Shinho Kim. Alright, so we're going to start off by building this code. Then we're going to go to tools or choose our tool layer 109. And then we are going to flash the code onto our board. So we're going to first show the speed down, speed up, and max speed functionality. So we're gonna start by going down. Now we're gonna go all the way up. Now I guess we can test max speed out. That's max speed. Now, so yeah, there's a speed level indicator. All four LEDs means fully on. All four LEDs off means fully off. So single button press, single action. That is in fact, that does one action. As you can see, and then so speed levels do not overflow, underflow. So here we can actually try to overflow the max speed, and then we can try to underflow the minimum speed. Does not underflow. Does not wrap around. So yeah, all right. Now I will discuss my code. Sorry to keep you guys waiting. All right, so here is my code. Here I have all my variables, or all my registers defined. Here I have all my constant values defined. I decided to define a constant that held the binary value for the max speed on my board, just to make it easier for me to increase my board to max speed at the very beginning of my program, and also at max speed. And all the rest of this is just copied from Lab 1 bump bot routine. And I used interrupts. Mostly used the code from Lab 5 to do this project. So here I have speed up set to 002, speed down set to 004, and speed max set to 00008. Yeah. And then here I initialized my stack, or actually I initialized my counter. I set to 255. So my program starts off at max speed. And then here I set my max value to 255, my minimum value to 0, and my port B output to 0. And I'm going to be using this to actually load values onto port B. Yeah, I'm going to be using this to load values into port B. All right, so here I initialize a stack. Here I configure my port B. Everything is going to be an output. All pins are going to be outputs. Here I configure port D. Everything is going to be an input. Here I configure my external interrupts for button 1 or PD1, for PD0, PD1, and PD3 to fully high, because for some reason I was having problems with the rising edge configuration. So I did that. Here I cleared all flags, and here I actually enabled my interrupts for int 0, int 1, and int 3. And then here I initialized my 16-bit timer counter, 1A and 1B, to fast PWM 8-bit mode with no pre-scaling. The no pre-scaling part is right here. And then here I loaded OCR1AL or low with counter, so that the motor's at max speed. And then here I just preloaded some, I just set the tech bot to move forward on port B. So I loaded move forward into NPR and NPR into port B so that the tech bot is initially moving forward. And here I, since I set the motors to full speed, I don't want to corrupt those values or change those values to high, because that would mess the values up stored in bits in the upper nibble of port B. So I instead decided to, first thing I did was I preserved the upper nibble of port B by ANDing NPR, which stores the output of port B with 1, so that the upper nibble isn't changed. And then I loaded a full speed into port B output, which is just the full speed on PB 0 to 3. And then I ANDed NPR in port B output, and then I just outputted that to port B to give me the initial full speed for my motors, as well as the initial max speed level. And then here my function is speed down. Here I push my registers onto the stack. Here I disable the interrupt for int 1, which is the interrupt that is used in speed down, which is the interrupt used to trigger speed down. And then here I put a kind of wait function, because I was actually having problems with the button. For some reason, it kept it would trigger multiple speed level changes, so I had to add a counter to fix that. Or not a counter, sorry, a kind of wait function, a delay function, that's what I was trying to say. And then here for loop 1, first I compare counter to minimum value. If these values match, the program will exit out of loop 1 and just return. But if it doesn't, then I load 17 into NPR, and then I decrease counter by 17 to decrease the speed of the motors, as well as the speed level shown on the lower nibble of port B. So I then load counter into ACR1AL low and ACR1B low, and then I here I modify PB0 and PB3 without corrupting the value stored in the upper nibble of port B by doing the exact same thing I did in initialization, which is here I loaded counter into register 21. Then I removed the upper bits of counter, and because I just want the lower bits. And then I got the value being outputted in port B, and then I preserved the values stored in the upper nibble of port B by ANDing it with 0B11110000, and then I ordered both of these, the values, the value I want to output in the lower nibble, and the value I want to preserve in the upper nibble, and then I ordered these to combine them, and then I just outputted the result into port B. And then here, once I reach the end of this, of everything, of all the code inside loop 1, I'm going to jump to exit 1. And then here I'm just going to re-enable the interrupt for int 1, which is what triggers speed down. And then clear all the flags for int 1. And then I'm just going to return from this subroutine. So yeah, I also pop all the registers from the stack, and speed up is exactly the same, except I load 17 into MPR, and then I add MPR into counter, and then that's basically it. It's the exact same. This speed up is the exact same as speed down, except that I'm adding 17 to counter instead of subtracting. So for speed max, all I do is first I disable the interrupt for int 3, and then I basically just initialize ACR 1A to the ACR 1A and B to their max value so that the motors are at full speed. And then I load full speed into port B output, and then I get the output from port B. I preserve the upper nibble by ending it with this expression right here, and then I combine the full speed command with the values being outputted to on port B in the upper nibble, and I output that at port B, and here I re-enable all interrupts, and then I clear all pending flags, and then I return back for my subroutine. So that's basically it. All right, thank you.